We're looking at this, the radical right here. Okay? The way that you are going to simplify this first step, where there's no power that's greater than the index, is you're looking for groups of whatever n is. So in this first example, our n value is 3, a cube root. So what we're doing in our powers here is we're looking for groups of 3. We're removing that many groups out of the radical and leaving whatever's left inside. So when we take this value, I'm going to kind of split it into what we remove and what stays in. And if we just move from base to base. Okay, so looking at our base x, how many groups of 3 can we remove from 12? 4. So that comes out as x to the 4th. When we remove 4 groups of 3, how many x's are going to be left inside? 4 groups of 3 is 12. 12 removed from 12 leaves 0. So there's no x's that are left inside. Okay, so we move to the next base, y's. How many groups of 3 can we remove from 16? 5. So that comes out as y to the 5th. We removed 5 of those groups of 3. 5 threes is 15. So after removing 15 of these y's, how many y's are left inside? 1. So we leave that one y inside. And then we move to our next variable, z, the base z. How many groups of 3 can we remove from z's? 7. 7 groups of 3 is 21. Removed from 21 leaves how many z's inside? 0. So this would be your answer. Okay. When you are entering your answer as a radical, you can use the equation editor. The yellow arrow key will pull up the equation editor. But you can also, in this, you would say x to the 4th, y to the 5th, z to the 7th. What you can do, again, is use root. This is different than the T89. If you're going to enter the square or the nth root on the MyOpenMath, the first thing that you'll put after the word root in parentheses is the index. So this would be root parentheses 3. And then you'll set another set of parentheses, and you'll put whatever is inside your radical. So we only have a y inside. Close that off. So this is how you would enter the information from that first problem. So when we're looking at this next problem here, our index is 7. Okay, so we're looking for groups of 7 from each of these powers. So when we look at our base x, again, what I'm going to do here is split my field into what's pulled out of the radical and what stays inside. So my base x, my power is greater than my index, so I know I'm going to remove some x's. And I want to remove however many groups of 7 I can from 19. So how many groups of 7 can I remove from 19? 2, right? 2 groups of 7 is 14. That leaves how many x's still in my radical? 14 removed from 19 leaves 5. So now I can move to my next base. 11 is greater than 7, so I know I'm going to remove some y's. How many groups of 7 can I remove from 11? 1, so it just comes out as y. And I'm going to be removing 1 group of 7 from 11, so that means how many y's are left inside? 11 minus 7 leaves 4. So next I look at my next base z. The power of z is greater than the index, so I know I am going to pull at least 1 out. How many groups of 7 can I remove from 9? 1. And that leaves how many z's inside when I remove 1 group of 7? 2. And so this would be my simplified